morning, everyone. Today we are going to be looking at scale. Our objectives for today and our intent is to look at converting units of length, calculating conversions of scale maps, calculating conversions of scale drawings, and then drawing scale diagrams. So first, we're going to have a look at scale maps. So some things, scale is used because some things are drawn using a scale because they're too large to draw in real size. So for example, anything that you have on maps, blueprints, model cars, even when you're like redesigning your kitchen or any part of your house, you will take it to somewhere like B&Q, you'll take it to somewhere like IKEA. They'll create a scale of the room that you're redesigning, add in all the furniture and units that you need, and then create that in real life. And one of the really important things to remember a scale is remembering those units of length. And our little conversion diagram is going to be really helpful whenever we are converting anything in scale, because on both the non-calculator and the calculator paper, these questions do come up. So converting units without a calculator. So if you need to convert a measurement, for example, like a centimetre to a kilometre, it's really important that you do the conversion in stages rather than all at once. It'll help minimise any kind of errors that happen and things like that. So say we have to do 150,000 centimetres to kilometres. First, we'll convert the centimetres to metres. So we're going to divide by 100 because centimetres to metres we divide by 100, which leaves us with 1,500 metres. We're then going to take that 1,500 metres and we're going to convert it to kilometres by dividing by 1,000, which then leaves us with 1.5 kilometres. So effectively, instead of kind of rushing through that conversion, we've done it slowly in stages, taken our time, and we've got to the correct answer. So we're going to have a go at a couple of these. So we're going to convert the following: 250,000 centimetres to kilometres. So we know we're starting with centimetres and our end goal is to get to kilometres, but we're going to go to metres first. So we're going to do 250,000 centimetres, our little arrow, and then metres. And to get from centimetres to metres, we've got to divide by 100. Now, there's two ways in which we can do this. 100 has two zeros, so we can knock off two zeros in our number, or we can start moving decimal points. So we need to imagine our imaginary decimal point is here, and we're going to move it two places to the left. So we're going to go 1, 2, and our number ends in 2500, which is 2,500. Same effective if we got rid of two zeros, 2,500. We've now got our 2,500 metres, and we're going to convert this now to kilometres. So this is our final step: 2,500 metres to kilometres. Metres to kilometres we divide by 1,000. So now we do not have the necessary number of zeros because we'd need 3 zeros in order to knock off the 3 zeros. So we're now going to divide by 1,000 by moving our decimal places. So we start here, we're going to go 1, 2, 3, and our answer is 2.5 kilometres. Okay, that's our first one done. We're then going to look at our second, and this time we're going to have to do things in reverse. So instead of moving to a smaller measurement to a large, we're starting with a larger measurement and moving to a smaller one, which means we're going to have to now multiply. So we're starting with 0.13 kilometres. I'm going to convert that to metres first by multiplying by 1,000. So that decimal point now is now going to move 3 places to the right. So we're going to go 1, 2, then notice we don't have anything after. So it's actually, if we add in an imaginary 0, we're going to go 1, 2, 3, and our answer is 130 kilometres. Sorry, 130 metres. We're then going to take that 130 metres and we're going to make it centimetres by now multiplying by 100. And what's a nice, easy, effective way of doing this now, because we've got a whole number and not a decimal, we can now just add the 2 zeros to our answer. So we've got 130, we're going to add 2 zeros, and we're left with 13,000 centimetres. And that is how we convert units without a calculator. So now we can do this, we can now effectively start looking at scale maps. So a map scale tells you how far a given distance on a map is in real life. So for example, a scale of 1 centimetre to 1 kilometre means that 1 centimetre on the map equals 1 kilometre in real life. And a super easy way of remembering it is if you always write it a little bit like a ratio, so 1 centimetre paper, dot, dot, 1 kilometre real life, You then understand what each part of the scale represents. So having a look at our scale map on our left-hand side, we know our scale is 1 centimetre to 5 kilometres. And if we changed either side of the scale, the other side has to be changed by the same route. So say we wanted to know the distance between Fleetly and Coniston, and we pulled out a ruler and that measured 2 centimetres, and we wanted to know what it was in real life. Easiest way to do it, put your 2 centimetres underneath your 2 centimetre measurement. And because you're going from paper to real life, you're going to multiply. And you're going to multiply always by this number. So 2 centimetres times by 5 is 10 kilometres. And that's how we get our real life measurement. Now, say you had a real life measurement and you wanted to know what the map measurements are. Well, let's have a look at that. So a map is drawn on a scale of 1 centimetre to 2 kilometres. If a road is 12 kilometres long in real life, how long will it be in centimetres on a map? So our first step, what we're going to do is we're going to write the scale as a ratio on words, paper and real life, as we've just done. So 1 centimetre on paper is 2 kilometres in real life. Our second step is under the real life measurement, write the measurement in the question. So because we've got kilometres here and kilometres in our question, our 12 is going to go underneath our 2. And then our top tips for scale questions is this. Follow the ideas. From paper to real life, we multiply, and from real life to paper, we divide. So because here we've got real life and we want paper, we're going to do 12 divided by 2, which gives us 6 centimetres. And as said, we do 12 divided by 2, which tells us 6 centimetres on paper. So if you start with the paper and you want real life, you're going to multiply. If you start with real life and you want paper, you're going to divide. So let's have a go at some of these scale questions. So we've got 1 centimetre to 10 metres. What would 5 centimetres on paper be in real life? So we've got 1 centimetre to 10 metres. Our question says 5 centimetres here. So what would be our real life? So we're starting with paper. We want our real life. So we're going to times by 10. So our answer is 5 times 10 is 50 metres. And that's question 1 done. Let's now have a look at B. So our scale is 1 centimetre to 20 kilometres. And our question's asking what would 100 kilometres be? So we put our 100 underneath our 20. And now because we're starting with real life and we want paper, we're actually going to divide now. So 100 divided by 20 is then 5 centimetres. Now, really important, if we cannot do a division in our head, we always put it into bus stop. Okay, it's the easiest effective way to do any division. Then we've got 1 to 100 metres. And our question says, what would 4 centimetres be in real life? So now when we know we're going to put that 4 underneath the 1. We're then multiplying because we want real life. So we've started on paper and we want real life. So we're going to do 4 times 100, which is then 400 metres. And that's some nice, easy, effective scale questions and calculations. So now let's have a look at an exam style question. So this would pop up on the non-calculator paper. So it says here, a distance between 2 villages on a map measures 6 centimetres. A map has a scale of 1 to 25,000. What is the actual distance between 2 villages in kilometres? So here we're starting with centimetres. And we need to end up in kilometres. So first, as normal, we're going to write out the ratio and the scale. So 1 centimetre is equivalent, no, it says 25,000, so it's not going to be in kilometres, that's going to be in centimetres, because it's going to be too big to be in kilometres. Now, it says our map measures 6 centimetres. So we're starting with paper, we're being asked to find real life. So we're going to multiply by 25,000. Now, a nice easy way to do it is to do 6 multiplied by 25, which is 150, and then add in your zeros. So then we're going to be 150, 3 zeros, 150,000 centimetres. Now we know our real life measurement. So step 2 now is we've got to convert 150,000 centimetres to metres. So to kilometres. But first we're going to do it to metres. So step 1, we're going to do 150,000 to metres. So we're going to divide by 100. So we knock off 2 zeros and we're left with 1,500. And then step 2, we're going to do 1,500 divided by 1,000 to get to kilometres. So we're going to move our decimal point. We start here, 1, 2, 3, and our answer is 1.5. And that is our answer. So what we've done, we've written out our scale, we've multiplied our paper measurement in real life to get 150,000 centimetres, and then we've converted that to kilometres. And that is scale maps done. Our next topic with scale is scale drawings. So this is where we're given a drawing and we're asked to convert that back to real life measurements based on an image or a sketch. So with scale picture questions, it's really important to remember, multiply your measurements by the scale. And what this means is the second number on your scale, so for example 1 to 50, 1 to 400, 1 to 200, you're always going to multiply by that second number. Your second step is you're going to convert it to the correct measurement, and then third step, work out what's needed in the question. So often it's like area, perimeter, diameter. So let's see how these work. So our first question says an estate agent needs to know the area of the plot of building land. So already we're being asked to calculate area. And this plan shows the building land. So this is what our measurement's in. So 16 millimetres, 66 millimetres, and our scale is 1 to 1,250. So the scale is in millimetres. And give your answer in metres squared. So that's what we're going to convert our measurements to. Okay, so step 1, we're going to multiply our measurements by the scale. So step 1, our measurements on our picture are 16 and 66. So we're going to do 16 times our second number, which is 1,250. And then we're going to do 66 times 1,250. These would be calculator questions. So we're going to pop them in our calculator and we get 20,000 millimetres. And then 66 times 1,250 is 82,500 millimetres. And that's our first step done. So now I'm going to change the colour of my pen while we do step 2. And we're going to convert the measurements in our question, which is metres. So we're going to do, because we've got a double step to do, we're going to do it in stages. So we're going to do 20,000 millimetres to centimetres, which is we divide by 10, which is then 2,000. And then 2,000 centimetres to metres, which we divide by 100, which is then 20 metres. And we're going to do exactly the same with 82,500. So 82,500 millimetres divided by 10 to get it to centimetres, which is then 8,250, and then 8,250 metres to centimetres, we divide by 100, onto 82.5. And now we've got our measurements in real life. Now our question is now asking us for area. So we know to calculate area, we're going to do the length multiplied by the width. Now this is what's really important. Our length and width are no longer 16 and 66 because we've converted them using the scale, and they are now 20 and 82.5. So 20 times 82.5. We're going to pop that into our calculator, which gives us 1,650 metres. And that is our answer. And we've done all 3 steps to get us there. Okay, let's try that once more with another question. So John is opening a healthy eating cafe. He looks for property with a seating area for 20 customers. This is a scale plan of the seating area in one property he finds. The drawing has a scale of 1 centimetre to 150 centimetres, and our diagram shows it's 4 centimetres and 3 centimetres, the image that he's drawn. The recommended maximum number of customers in a cafe is the seating area metres squared divided by 1.5. Is the property suitable for 20 customers? So we're going to follow our steps again. Number 1, we're going to multiply by our scale. So our scale is 1 to 150, so that's what we're going to multiply our 4 and 3 by. So 4 centimetres times 150 and 3 centimetres times 150, and we've got 600 centimetres and 450 centimetres. And then our next step, we're going to convert to the measurements that we are looking for. And here we notice it says metres squared, so that's going to be what we convert to. So this time we don't have to do a double step, we only have to do it once. So 600 centimetres to metres, we're going to divide by 100, which is then 6, and then 450 centimetres divided by 100 is then 4.5, and we've got our conversion of our units. Then, wondering what we do next, we have to read the question. So notice seating area, and metres squared tells us we need to work out the area. So as before, step 3, we're going to calculate the area by doing the length times the width. Now our units are no longer 4 and 3, we've just calculated them to be 6 and 4.5. So we're going to do 4.5 times 6, which is then 27 metres squared, and that is our area. But that is not the end of the question, so I'm going to now add in a last step. So here it says the recommended maximum number of customers in a cafe is the seating area metres squared divided by 1.5. So here we actually have a formula, and that formula is saying to work out customers, we do the area in metres squared divided by 1.5. So that's what we're going to do to work out if the customers is going to be 20 or more or less. So we're going to do customers equals 27 divided by 1.5, and that gives us 18. So is the property suitable for 20 customers? No, it can only fit 18. And that is our scale drawings. So now we are on to our last element of scale, which is actually drawing scale diagrams where we're given some measurements and we have to transfer those images onto graph paper. So, for example, when we're drawing scale plans, in the exam you might be asked to draw a scale plan, which means create a downsized drawing on graph paper. To do this, we have 3 steps. You change your measurements of your images to centimetres. Now, if it's already in centimetres, you can skip this step. You then divide your measurements by the scale, so that second number, and then you draw your measurements on paper. So let's have a look at an example question. So the graph paper here has just been blown up, so it's easy for you guys to see. It'll obviously be smaller on the day on your exam. James wants to draw a scale plan of his garden. His garden is 2 metres long and 1 metre wide and is shaped as a rectangle. His scale is 1 to 50. Draw James's garden on the graph paper. So first we're going to change our measurements to centimetres, and we've got 2 metres and 1 metre. So to change to centimetres, we're going to multiply by 100, which gives us 200 centimetres and 100 centimetre. Our second step is then to divide the measurements by the scale. So our scale is 1 to 50, and we're going to divide by this number. So we're going to do 200 divided by 50, and 100 divided by 50 gives us 4 and 2 centimetres. And that is what our measurements are going to be on paper. So now if every box is 1 centimetre, how many will 4 and 2? So we're going to count 1, 2, 3, 4. We're going to count 2 down, join them together. And then what's really good to remember whenever you're drawing any image is in the centre to make a note of what the image is that you're drawing. And here it's a garden. Let's have another go at one of those. So a little bit more complicated this time. So Sally wants to draw a scale plan of her bedroom. The bedroom is 2 metres long and 1 metre wide, and in her bedroom, her bed is 0.5 by 0.5 metres and wants to be placed in the top right-hand corner. Her scale is 1 to 50. Draw Sally's bedroom on the plan. So we're going to change our measurements, and we've got 3 now to deal with. So we're going to do 2 metres times by 100 to get 200 centimetres. 1 metre times 100, and we're timesing by 100 because we're converting from metres to centimetres, is 100 centimetre. And then 0.5 metres times 100 is then 50 centimetres. And we've done our first step. We then need to divide our measurements by the scale. So again, it's that 50 number. So 200 divided by 50 equals 4 centimetres. So that's the length of our bedroom. 100 divided by 50 is now showing the width, which is 2 centimetres. And now her bed. Now we don't need to do 0.5 twice because we've already got it once. So now our 50 centimetres divided by 50 is 1 centimetre. And that's going to be our measurements on paper. So if one box is 1 centimetre, her bedroom's going to be 4 boxes across, 2 boxes down, and we've got her bedroom. Now, what's really important is that you're going to do this with a ruler on the day, but it's to remember things like this, which catches people out in the exam. So we're going to put the bed in the top right-hand corner. We know that it's 1 across, centimetre across, and 1 in width. So now we're going to write bed and then bedroom. And we now have Sally's scale plan of her room. So let's have a look now at how this applies to some exam questions. So our first one, a student wants to get some furniture for his room. He plans to buy this bed. He needs to know where it can fit in his room. The room is 3 metres long and 2.5 metres wide, and he draws a scale floor plan shown below. Add a scale plan of the bed showing where it can fit in the room. Now, what's really important here is we've got measurements of the room which are not needed for the question because we are only focusing on the bed. So our first step is to convert our measurements to centimetres. Now, here they're already done. So because the measurements are already in centimetres, we can skip this step, skip step 1. And then we just go into dividing by the scale. So we know our scale here is 50. So we're going to do 190 divided by 50 and 90 divided by 50, which gives us 3.8 centimetres and 1.8 centimetres. Now, as you can see on our paper, we have mini lines on our graph paper. So an entire line here is 1 centimetre. And we have now got 3.8 and 1.8, and we're not going to guess. We're going to do this accurately. So what you're going to do is you're going to look, each box is 1 centimetre, and there are 5 mini lines. So each box equals 1 centimetre. In each box equals 5 mini lines. So what we do to work out the mini lines or the increments is we do the total between the lines, which is 1, divided by how many lines there are, which gives us 0.2 centimetres. So each mini line is worth 0.2. So now we can count. So we're going to go 3.8. So we're going to do 1, 2, 3, 3.2, 3.4, 3.6, 3.8, and that's where we're going to start the bed. Now, we're going to go down, our width is 1.8. So we're going to go 1, 0.2, 0.4, 0.6, 0.8. Then we're going to join these lines up and put the bed. Now, what's really important is to understand the question isn't telling you where to put the bed. It's asking you where it can fit in the room. So if you wanted to do it down here, if you wanted to do it down here, if you wanted to do it, as long as it doesn't cause problems with the door, then any part of where you have put this bed on this graph paper is correct. The important part to get the marks in this question is that you've worked out the measurements and that you've correctly identified where 3.8 and 1.8 is on the graph paper. Okay, we're going to do one more question on this, and this is a bit of a larger question, so there's a couple more steps that are needed. A kitchen designer needs to draw a scale plan for his customer's new kitchen. The customer gives the kitchen designer this sketch to show how she would like the cupboards to fit on the worktop. The base of the large cupboard needs to be 50 centimetres above the worktop. Use the scale plan of the elevation of the kitchen wall to show where the kitchen designer should draw the cupboards. So this is what we call a front elevation. So it's looking at the shape flat on from the front, and that is what we need to draw here. We need to transform this picture here onto our elevation using our conversions and our steps that we've done. So what we need to now do is convert our images. And as you can see, there is something a little bit different here. We have got 3 measurements to deal with. Remember, you are only ever dealing with length and width. Here, this measurement here is the depth. So because this is 3D and we're transforming to 2D, you do not need that depth measurement. We are only dealing with length and width. So first, we're going to convert to centimetres. So we're going to do 750 millimetres to centimetres by dividing by 10, which is 75. And now notice these are all 50, so we don't have to do it 3 times. We can only do it once. We should only do it once, really. Convert to centimetres, divide by 10, and we're left with 50. And that's what our measurements are now on paper. Then we're going to divide by the scale. Now our scale is 25. So we're going to do 75 divided by 25, which is 3 centimetres. And then 50 divided by 25 is then 2 centimetres. So we know that is the length and that's the width. Now we can draw, but we don't actually know yet where we are starting our drawing from, but there is a clue in the question. And it says here the base of the large cupboard needs to be 50 centimetres above the worktop. Now, if you were drawing this with a ruler, you would go over this drawing if you were counting real life as 50 centimetres. But actually, with that 50, we need to convert on the scale. So the 50 centimetres, we need to divide by 25, which gives us 2 centimetres. So it needs to be a 2 centimetre gap above the worktop. So we're going to start 1 centimetre, 2 centimetre. We're going to start our measurements from here. So our first one, we know is 3 centimetres because it's the larger one. So we've got 2 large, 3 small. So we're going to go 1, 2, 3, and there's our first one. And we're going to go 2 across. And there is our first large cupboard. We're then going to do our 3 smalls, which we know are 50 and 50, or 2 and 2. So 1, 2, 1, 2. And we're going to do 3 of those. 3 of those. And then all we need to now do is just join our lines up. And we have got our elevation of our kitchen cabinets. And that is our scale. So we can now convert units of length, calculate conversions of scale maps, calculate conversions of scale drawings, and draw scale diagrams. So now the independent work that we need you to do There are two pieces, one on scale maps and diagrams and the other on drawings. So it is highly recommended with the drawings that you print it on paper, or if you want to have a go at electronically using the draw tool on Word, you can do. But now go off, create revision notes in these elements and have a go at the independent work.